Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you what to look for in the night sky, our weekly series. And we're kicking off 2022, January 3rd, 2022. That's the week of January 3rd, first week of 2022 we're going to talk about here. Three things we're going to think about and or observe in the sky. So it's a good start to 2022. Some things to look at. Last week, let's start in the evening sky. Last week we talked about trying to see Jupiter, Saturn, and Venus, and you maybe can still see all three of those. Venus is getting closer and closer to the sun, so it's good to go out in the evening sky and try to catch all three of those planets. And this week on the mornings, the evenings, of the 4th and the 5th, that would be Tuesday evening, Wednesday evening, you can see the moon move past Saturn and Jupiter. Remember that we were looking at Saturn and Jupiter here. Venus is down below, so there's Venus, Saturn, Jupiter. Venus and Jupiter are the two brightest of those three, and then Saturn is less so in between there, but still pretty bright. On the evening of the 4th, the moon will be a very slender crescent and quite near Saturn. It's going to be a striking view. So if you got one night to go out and observe something this week, go out on the evening of Tuesday the 4th and look at the moon near Saturn. And what a beautiful crescent moon. It's going to be very slender. By the next night, it will have moved up this direction. Recall again that we've talked about how we're using Deneb Algady in the tail of Capricorn to measure the motion of Jupiter and Saturn. We've watched that angle open out. The moon will have slipped up by the next night near Deneb Algady below Jupiter. So it's still going to be a very striking view in this region, as now the moon is between Jupiter and Saturn and actually quite close to Deneb Algady. And the moon will be twice as full. It's only about 6% of the surface is visible here, about 13% of the half that faces us, the surface that faces us. So it will be about twice as full here, but still a very slender crescent. So this is a wonderful thing to see. By the next night, it will have moved up this direction. Still good. So no reason to not go out on the 6th and observe it further up this direction. But 4th, 5th, 6th, go out and check out the waxing crescent moon as it moves past Jupiter, Saturn, and Deneb Algady here. So that's our first thing that we're going to look at. Now, when you're out in the morning, by now, Mars is rising 2 hours ahead of the sun. And that means we might be able to pull it out of the morning sky. So binoculars will help, but I suspect you might not need binoculars by now. If you can't find it this week, go out next week and the week after. One of these weeks, very soon, you're going to be able to find it. But my guess is by this week, you should be able to see the bright orange glow of Mars. Mars isn't at its brightest right now. It's not as bright as what we see going on here in the evening sky, but it's bright enough that you might be able to start to see that red dot in the glow of the sun. Now what's interesting is Mars is actually very close to Antares and Scorpius. And so Mars is here and Antares is down here, and Antares itself is quite orange. And so you might be able to see two orange-red dots in the morning sky, and binoculars might really help you do that. So that's what you're looking for, is to look for Mars and Antares, these two orange-red dots glowing in the morning sky, rising just before the sun. By the end of January, should be no problem. You should be able to see those really easily in the morning sky. In fact, I know it'll be no problem. And so you want to keep your eyes on this region of the sky. But I think by this first week, you probably can see both of these things, especially with binoculars. Antares is a little bit harder to see. It's a little bit further south and maybe a little bit fainter right now. And so, but it rises a little bit earlier. It's a little bit further east. So it rises a little bit ahead. It's a little bit further out of the glow of the sun to the east, but a little bit further closer to the horizon. And so it'll be interesting to see what you can see of those two objects. You might be able to see them both fairly easily. I don't know. Good luck. That's a great observing project to start this week. Watch the planets in the evening sky, then swing around and watch Mars in the morning sky, and think about that line that connects Jupiter to Saturn to Venus to the sun to Mars. So we got that flattened disk of the solar system, and you see the flattened nature of the solar system right there in a line in the sky, an arc in the sky that you see that connects all of these planets right through the sun to Mars in the morning sky. So just envision that geometry. When we talk about, when I teach the general astronomy class, one of the goals of the general astronomy class is to develop our geometrical imagination. That's the phrase we use in the class, is to say we want to build geometrical imagination. And so that's a learning goal, a learning outcome that we have, that we try to make progress, and we try to measure progress toward that. And so we're thinking about geometrical imagination, and that's what you're doing right here, is practicing your geometrical imagination, picturing what it would look like to sit outside the solar system and see that flattened disk, that flattened plane of the solar system, and then say, okay, now I'm on one of those planets that's in that disk. What does the rest of the solar system look like as I scan around the sky and see the planets? I don't look up here. I don't look down here. I have to look right along here, and that right along here is right there: Jupiter, Saturn, Venus, Sun, Mars. Okay, so look for Mars in the morning sky. See if you can see Antares with it. Going to be great. We said a little while ago, I think 2 weeks ago, in one of our videos, we talked about the difference between the sunset getting earlier and the sunrise getting later. By now, the sunrise is getting earlier and the sunset's getting earlier. The sunset's getting earlier a lot faster than the sunrise. So we're gaining daylight in the evening a lot faster than we're gaining daylight in the morning. And so, but we're gaining on both ends. So one of the things that we're going to do here is we are going to pass through perihelion. And so perihelion passage for us is going to occur on January 4th. And that January 4th is going to be, I think it's about 9 o'clock, if I remember correctly. It's going to be about midnight for me, so that's why it's confusing to me. It's about the transition from January 3rd to January 4th here is when we're going to be closest to the sun. So when you think about this, some more geometrical imagination for us is to say, so as we transition from January 3rd to January 4th, for me, it's going to be right on that transition time. We're going to have perihelion passage probably about 1 o'clock in the morning for me. So depending on where you are, if you're west of me in the United States, it'll happen on the overnight on the 3rd instead of on the 4th. And so what that means is we know that in general, the orbits of the planets around the sun, the orbit of anything around anything else, is an ellipse. Okay? A circle is a special case of an ellipse. An ellipse is this flattened circle, and we talk about the eccentricity of an ellipse. The eccentricity is a measure of the squishedness of that. That's a technical term. Go ahead, use it. The flatness, the squishedness of that ellipse. And so the flatter it is, the greater the eccentricity. The eccentricity can vary between 0 and 1, and you can think about it as a fraction. So this is a focus. That's a focus of the ellipse. So that distance right there and that distance right there, you have 2 points. If you take a line that connects, we call that the major axis, the line that connects one end to the other end. You come in the same distance on one end and the same distance on this end, and then you can mark the 2 focus points of the ellipse. The eccentricity of the ellipse is defined as that distance between those 2 points divided by that total distance right there. So you can think of it as the fraction of the entire major axis, the entire distance from one end of the ellipse to the other, that is covered by the distance between these 2 foci. As the ellipse becomes more and more circular, you get smaller and smaller eccentricity. Those 2 points merge, and when those 2 points are on top of each other, the eccentricity is 0. There's no distance between those 2 points. They're right on top of each other, and they cover no fraction of this major axis. We bring all of that up. You think, why is he talking about this? It was a good question. I don't know. But the eccentricity of the Earth's orbit is only about 1.7%. It's 0.017. So is the eccentricity of the Earth's orbit, which means the distance between the 2 foci covers about 1.7% of the total distance. So we're a little bit closer at perihelion. If that's the sun right here, that's perihelion and that's aphelion. and we're a little bit closer at perihelion than we are at aphelion. Not enough closer that you're going to notice it in terms of warmth, not enough closer that you're going to notice it in terms of the apparent size of the sun in the sky. If you measured very carefully, maybe, but just walking out and looking at it, don't look directly at the sun, but just walking out and looking at it, you're not going to notice any differences in anything like that. It's not any warmer because it's any closer or anything, but we are moving a little bit faster. So we're moving a little faster in our orbit here than we are here, and we talked about that last week. So we're right now, this week, that's what we want to think about. This week we are moving the fastest in our orbit that we are going to move all year. And that very, very fastest point where we're the closest to the sun, albeit just very slightly closer to the sun, is going to be either on, depending on where you are and where you are in the world, it's going to be somewhere on January 3rd or January 4th. It's that transition time again. For me, it's just before 1 in the morning on January 4th. So people who live in the United States, where I live, that live west of me in the United States, it's going to be before midnight on January 3rd. And those who live east, it's going to be after midnight on the morning of January 4th. And then you can figure out the rest of the world around there. But anyway, it doesn't really matter. What matters is on this whole week, we're moving faster on average than we are at any other time during the year. We're going to reach our fastest point early in the week. So think about that as you go out and observe. Think about that as you see the stars rise and set, and everything looks constant, and everything looks like it's moving along at a steady pace, and more or less it is. But things are happening. We're moving in our orbit just a little bit faster, and what that means is when we move in our orbit a little bit faster, we cover a little more ground in our orbit. And if we cover a little more ground in our orbit, that means, as we talked about a couple of weeks ago, there might be a slightly bigger difference between the sidereal day and the solar day. It might take a little bit longer for sunset to come back around and catch up. And so we see those sunsets getting later and later and later for those of us in the northern hemisphere. Anyway, that's what we got this week. Ignore all of that last stuff if you want to, if geometry is not your thing, if you're not about these ellipses and just thinking about where we are in our orbit and what's going on. But do go out and see if you can find Mars and Antares in the morning sky, and do go out and watch the moon as it's waxing. Very thin crescent moon waxing and moving past Saturn, Deneb, Algady, and Jupiter in the evening sky. It's a great start to 2022. I hope you all have a good year ahead, and we will have more for you next week. Thanks, everybody.